Ukrainian armed forces continue to unveil innovative and increasingly powerful ways to resist the invading forces of the Russian Federation. They've not only created entirely new weapons, ranging from high-speed ballistic missiles and long-range cruise missiles to artificial intelligence-powered air defense turrets, but also revitalized and modernized old military concepts from the Cold War era. By bringing these once-dated technologies into the 21st century, Ukraine has turned them into precise and devastating tools of warfare that Russia struggles to defend against. The Ukrainian armed forces continue to unveil innovative and increasingly powerful ways to resist the invading forces of the Russian Federation. They've not only created entirely new weapons, ranging from high-speed ballistic missiles and long-range cruise missiles to artificial intelligence-powered air defense turrets, but also revitalized and modernized old military concepts from the Cold War era. By bringing these once-dated technologies into the 21st century, Ukraine has turned them into precise and devastating tools of warfare that Russia struggles to defend against. One of the most remarkable examples of this transformation is Ukraine's use of laser-guided munitions. To truly understand how Ukraine has adapted this technology to its advantage, it's important to first understand how such systems function. Laser-guided weapons work by following a laser beam directed precisely at a target. A laser designator creates and focuses this beam on a chosen point, producing a distinct high-contrast spot visible even from long distances to sensors inside the guidance heads of bombs or missiles. Once those sensors lock onto the illuminated target, the weapon adjusts its trajectory to home in and strike with extreme precision. Developed in the 1960s, these munitions solved one of the biggest problems in early military aviation: accuracy. In the early days of bombing, most weapons were painfully imprecise. Studies from the 1940s revealed that only a small fraction of bombs landed anywhere near their intended targets. For instance, a British report from 1941 found that only 1 in 3 bombers managed to drop bombs within about 8 kilometers of the intended mark, while a post-war American study revealed that fewer than 1/3 of bombs landed within 300 meters, even when using the advanced Norden bombsight system. This level of inaccuracy meant that enormous quantities of bombs were wasted and countless missions failed to achieve their objectives. The introduction of guided systems, beginning with the American Bolt 117, first tested in 1968, marked a revolution. Though these early smart bombs were expensive and complex, they became integral to modern warfare by the 1980s and were famously employed in conflicts such as the 1991 Gulf War and the 1999 NATO intervention in Yugoslavia. Laser-guided munitions offered unprecedented precision, enabling militaries to destroy key enemy assets like fortifications, ammunition depots, command centers, and air defenses with surgical accuracy. They also brought several key advantages: the ability to strike moving targets in real time, the need for far fewer bombs to achieve the same effect as older unguided munitions, reduced risk and cost through fewer sorties, and a dramatic reduction in collateral damage. But despite these benefits, laser-guided weapons still have their limitations. Chief among them, the need for a laser designator to maintain direct visual contact with the target. Because of this limitation, new technologies have emerged over the decades, including satellite-guided bombs that can strike predetermined coordinates without the need for visual guidance. Still, laser-guided munitions remain widely used by many of the world's most advanced militaries, Ukraine included. Ukraine first began integrating this technology in 2019, when it ordered Turkish Bayraktar TB2 drones, along with laser-guided munitions such as the MAML mini-bombs, carrying 10-kilogram warheads, and the smaller MAMC bombs with 2.5-kilogram payloads. The TB2 drones acted as both reconnaissance and laser designation platforms, allowing these bombs to strike precise targets from the air. These weapons proved devastating in the early months of Russia's full-scale invasion in 2022. Bayraktar drones successfully eliminated Russian logistics convoys, air defense systems in Crimea and Kharkiv, and even struck key positions during the legendary battle for Snake Island. At that time, Russia was entirely unprepared for the precision and agility of drone-based laser warfare, and Ukrainian strikes destroyed numerous ships, missile launchers, and communication hubs. However, as the war dragged on, Russia adapted its defenses, and Ukraine needed to evolve once again. The country received large quantities of Western-supplied precision munitions, including satellite-guided weapons such as French AASM, Hammer bombs, American JDAMS, and GBU-39s. These bombs, though primarily GPS-guided, can also operate using laser designation, a crucial advantage given Russia's sophisticated electronic warfare systems capable of jamming satellite signals. When GPS guidance becomes unreliable, laser targeting provides a vital alternative. Ukrainian forces have since mastered the art of laser warfare. Among their most notable tools is the American AGR-20 Advanced Precision Kill Weapon System, or APKWS, a laser-guided upgrade for the 70mm Hydra 70 rocket. These rockets can engage both ground and airborne targets, enabling Ukrainian defenders to shoot down Russian Shahed drones with astonishing precision. By 2024, Ukraine had also begun deploying laser-guided artillery shells, such as the 155mm M712 Copperhead, supplied by the United States. Fired from howitzers at ranges of up to 16 kilometers, these rounds gave Ukrainian gunners a way to destroy fortified targets or moving vehicles with pinpoint accuracy. Yet the fundamental problem remained. Laser designation requires direct visual illumination of the target. On the heavily defended front lines of Ukraine, where Russian air defenses saturate the sky, keeping aircraft close enough to paint targets with lasers is both dangerous and often impossible. Ukrainian pilots can't afford to hover in enemy range long enough to maintain a steady lock, and losing valuable jets or bombers would be disastrous for a nation with a limited air fleet. Countries would see this as an unsolvable problem, but not Ukraine. Since the very beginning of the war, the Ukrainian armed forces have demonstrated extraordinary ingenuity, finding creative solutions to seemingly impossible challenges. Faced with this obstacle, Ukrainian engineers conceived a brilliant alternative. If manned aircraft can't stay close enough to guide the lasers, why not use something smaller, cheaper, and more expendable, a drone? Ukraine is already a world leader in drone warfare, having built both defensive and offensive capabilities that have repeatedly shocked the Russian military. Ukrainian drones have intercepted enemy UAVs, attacked oil facilities deep inside Russia, destroyed ammunition depots, and crippled airfields hundreds of kilometers from the front. Using drones as laser designators was a natural evolution of this technological mastery. Drones are compact, inexpensive, difficult to detect, and can be produced in large quantities. They're perfect for marking enemy positions without risking pilots' lives. Several Ukrainian defense companies quickly began developing such systems, integrating lightweight laser modules into unmanned platforms. One of these innovators is FRDM, which achieved a major breakthrough in July 2025 when its UAV-based laser guidance system was officially approved by Ukraine's Ministry of Defense. The system features a 6.5-kilogram laser targeting module mounted on an R-34 quadcopter drone. The module itself, while not Ukrainian-made, is ideally suited for local conditions. It combines a powerful laser designator, an optical observation system for visual tracking, and sophisticated software for real-time target acquisition. It can illuminate targets up to 5 kilometers away using a 70 millijoule laser beam, though performance naturally depends on weather, dust, and smoke conditions. These drones can work with both air and ground forces, guiding precision airstrikes and artillery attacks alike. An FRDM representative named Anton explained how the system operates. These systems serve both our air and infantry units. Infantry teams launch a drone carrying the laser module, designate the target, coordinate with aircraft, and then execute the strike. We focus not only on helicopters but also on JDAMS and, naturally, drone-launched munitions. Anton added that the ammunition used must comply with NATO standards, a critical point, since vast stockpiles of compatible laser-guided weapons already exist across the alliance. With NATO's continued commitment to supporting Kiev, it's likely that even more such munitions will soon make their way to Ukraine, paired with drone-based designators to ensure maximum effectiveness. FRDM's CEO, Vadim Yunik, summed up the philosophy behind the project. Using drones for laser designation isn't just more efficient than relying on fighter jets or bombers, it's also much cheaper. The laser guidance technologies developed in Europe so far are extremely expensive. Our goal is to make these systems more affordable. Ukraine needs a large number of them. As with any cutting-edge system, it will take time and training to integrate drone-based laser guidance fully into Ukraine's armed forces. Each drone crew requires 3 operators, 2 pilots, and 1 laser specialist, and missions last roughly 35 to 40 minutes, demanding tight coordination and precision timing. And FRDM isn't alone in this race. Another Ukrainian defense company, specializing in fixed-wing reconnaissance drones, told Ukrainska Pravda that it has successfully integrated a laser guidance module into UAVs already deployed on the front lines alongside artillery units. These developments represent the next evolution of Ukraine's high-tech warfare, one that merges classic precision systems with modern drone innovation. By reimagining how laser-guided munitions are deployed, Ukraine has once again turned adversity into advantage, ensuring that even weapons invented more than half a century ago remain deadly and relevant in the 21st century battlefield.